Nuclear power has revolutionized the world. Some engineers and scientists aren't content with only using nuclear energy for general power grids, they want nuclear power everywhere. The items in this list are examples of engineers taking normal, everyday things and fitting them with nuclear reactors, just to see if they will work. This video will show 10 insane nuclear versions of normal things. Number 10. Convair B-36 nuclear airplane. Immediately after World War II, the world's superpowers invested in huge bombers to deliver nuclear payloads. Since nuclear missiles were still in their infancy, long-range bombers were the best way to bomb enemy targets. Although impressive in their own right, bombers have limitations. Even long-range bombers have a finite range. For the range problem, the United States turned to an exotic solution. U.S. Army Air Force commanders invested in tests to place a nuclear reactor inside a bomber. At the time, the chief USAF bomber was a gigantic B-36 Peacemaker. The plane was big enough to carry a nuclear reactor on board, and still fly. Convair engineers modified the B-36 to carry a small nuclear reactor, giving the plane unlimited range. Designated the B-36, the bomber underwent a variety of changes. To keep the crew safe from radiation, the crew compartments were specifically designed with radiation shielding. Engineers placed large water tanks around the reactor to absorb any escaping radiation. For the first flight tests, the reactor was not attached to the engines. Convair decided to use the B-36 as an aerodynamic test plane for the proposed X-6 bomber, which would be fully nuclear powered. Even with the nuclear reactor not powering the engines, the USAF was very careful with the B-36. The airplane had radioactive symbol markings, and the President of the United States had a special hotline installed to inform him of any crashes. During testing, the hotline was almost used when a smoke alarm went off in the reactor room. Despite a promising start, advances in conventional airplane technology and aerial refueling negated the usefulness of a nuclear-powered bomber. Public officials also raised concerns over the safety of such an airplane, leading to the project being shelved in the early 1960s. So many pieces fell back together now. What's your vision? Number 9. Chrysler TV-8 nuclear tank. During the Cold War, NATO commanders feared that the Soviet Union would use tactical nuclear weapons to turn the tide in a ground war. In the US, Chrysler developed a tank that was specifically designed to withstand a nuclear strike. The TV-8 never reached mass production, and was mainly a concept demonstrator, but it was the only serious attempt to design a nuclear-powered tank. To survive nuclear detonations, the TV-8 had a strange configuration. All of the critical parts of the tank were in the bulbous turret, including all of the weaponry, and even the engine. The turret was completely sealed from the outside world, and the crew used closed-circuit television to see their surroundings. Designed as a medium tank, the TV-8 had a standard 90mm gun. Unusual for a tank, the turret could not rotate, meaning that the crew had to turn the whole thing to aim at its target. The turret featured 2 mounted machine guns in a top cupola, which were aimed by the tank commander. Chrysler originally gave the tank a conventional power plant, but later investigated fitting it with a small fission reactor in the back of the turret, and making the tank electrically powered. After investigating the design, the U.S. Army decided that it provided insignificant advantages over normal tank designs, and the project fell out of favor. So many pieces fell back together now. What's your vision? Number 8. M29 Davy Crockett nuclear bazooka. It should come as no surprise that various forces in the Cold War developed insane weapon systems, but as we've already seen, NATO had the monopoly on odd usages of nuclear weapons. Faced with the danger of a Soviet ground invasion in Europe, the United States spent lots of money developing small nuclear weapons that could turn the tide in the event of war. Key among the proposed nuclear weapons was the M29 Davy Crockett. The Davy Crockett was a recoilless gun that shot a small nuclear warhead, making it essentially a nuclear bazooka. Originally, the Davy Crockett would have been carried into combat by a group of soldiers, and operated by a three-man team. Later, the Army modified the design to be carried on jeeps, and other Army vehicles. Unfortunately for the United States, the Davy Crockett was not a particularly effective weapon. Even at its highest setting, the rocket had a pitifully small blast radius. Also, the resulting nuclear radiation would have provided plenty of danger to future Europeans. The M29 was easy to use. Once in place, the crew would fire a small 37mm spotting round to figure out the distance to target, and the general launch trajectory. Even with the use of a spotting round, the Davy Crockett's accuracy was dreadful. During testing in Nevada, the shell rarely landed within hundreds of feet of the intended targets, a disconcerting reality for a nuclear weapon. Although the project had shortcomings, Davy Crockett guns saw deployment in Europe between 1961 and 1971. None saw combat usage. Number 7, Jupiter Icy Moons Orbiter Nuclear Space Probe. The Galilean moons of Jupiter have a variety of fascinating features. Chief among these is the possibility of oceans in the moons, specifically on Europa and Ganymede. Where there is water, there is the chance for life, and NASA is fascinated with this pole. To explore the moons, NASA and the Jet Propulsion Laboratory have proposed and designed a variety of spacecraft to explore the moons. One of the most interesting was the nuclear-powered, and futuristic-looking Jupiter Icy Moons Orbiter, JIMO. JIMO was the practical application of NASA's Project Prometheus, which investigated using nuclear power to propel spacecraft ion engines. The project showed that not only was a nuclear-powered space probe possible, but it would grant unprecedented possibilities to exploration missions. JIMO would have much more available electrical power than the current generation of NASA probes. This would have allowed the probe to explore the 3 icy Galilean moons in one mission. After spending time orbiting one moon, JIMO would be able to fire up its nuclear-powered engines, and make the trip to the next moon for further exploration. When it came time to allocate funds, NASA was optimistic for the new spacecraft, and the possibility of actually investigating the Galilean moons for life. However, budgetary problems soon surfaced once NASA realized how ambitious the project actually was. As discussion over the JIMO program pushed on, NASA executives realized that it was far too costly for the organization, and had to move on to less ambitious projects to explore the moons. Number 6, Ford Nucleon Nuclear Car. Before nuclear power became more frightening, it promised a whole new generation of long-lasting and clean power sources. It should come as no surprise that during the 1950s, after some text, and click listen, engineers and manufacturers tried to figure out ways to use nuclear power for a variety of tasks. Most never left the head of the person thinking about them, but Ford pushed ahead with an ambitious design to put a nuclear. Named the Nucleon, Ford's concept car was designed with range in mind. Had the necessary technology to actually build one existed, for example small enough reactors and light enough shielding. Each Nucleon would have been able to go 8,000 kilometers, 5,000 miles, before its reactor would need to be recharged. Instead of trying to figure out a way to refuel the reactor, Ford planned to have recharging stations that would simply swap out an old reactor. Conceptually, these recharging stations would have taken the place of standard gas stations, but they'd have radioactive material. Number 5. Project Pluto nuclear jet engines. In the late 1950s, the United States began to earnestly develop intercontinental ballistic missiles and cruise missiles. The Air Force performed many experiments to develop the most devastating and effective missiles. One of the weirder and more terrifying projects was Project Pluto. This secret defense initiative developed a nuclear-powered ramjet engine that would give thrust for the Vought Slam missile. Although the missile itself never got off the drawing board, its exotic propulsion device did. Ramjets work by forcing air through the engine at supersonic speeds, which causes compression and thrust. Project Pluto engines had an unshielded nuclear reactor running inside of the ramjet. Because it did not have a sheath, the reactor would heat up the air in the engine, and greatly increase the available thrust for the missile. Using the ramjet, the SLAM missile would accelerate to Mach 4 to strike and cause huge amounts of damage. The first nuclear ramjet, called Tory IA, started testing in 1961. Ground testing continued for 3 years in Nevada, far away from any civilization. During the tests, the ramjet was extremely powerful and would work very well for the SLAM missile. However, as testing went on, the Air Force realized that the missile was too dangerous even for them. There would be no safe places to test the nuclear-powered cruise missile, and the reactor could never be turned off. If it survived the strike, there would be a running, and unshielded, nuclear reactor hanging out in the strike zone. Fortunately, the Air Force considered the risks too great and canceled the project. Number 4, the Lenin nuclear icebreaker. Icebreaking is an important job in cold northern seas. Without ships designed specifically to break up ice, most cargo would not be able to travel, effectively halting trade to northern countries like Russia. Before the fall of the Soviet Union, icebreakers were commonplace, but all very severe limitations on how much fuel they could carry. To rectify the problem, Soviet shipbuilders decided to put a nuclear reactor on an icebreaker, creating the Lenin. A ship that was both the first nuclear icebreaker, and the first nuclear-powered surface ship in the world. The Lenin first launched in 1959 and was as much a scientific statement as a practical ship. Nobody had created a ship like it before, and it showed Soviet engineering prowess while also demonstrating that they were using nuclear power for peaceful purposes. Initially, the ship's performance was exemplary, and the Lenin ushered in a new generation of ships for the Soviet Union. Using the nuclear reactor, the Lenin made a variety of Arctic expeditions, and was eventually awarded the Order of Lenin in 1974. This was the Soviet Union's highest award, usually given to soldiers in the line of duty. Since the Soviets were so proud of their icebreaker, they made an exception. Prompted by the success of the Lenin, Soviet shipbuilders constructed a fleet of nuclear icebreakers. On the 50th anniversary of its launch, the Lenin was retired in Murmansk, where it now resides as a museum. To this day, the ship remains an artifact of the early nuclear era, and one of the most influential ships of all time. Number 3, Project Oil Send nuclear oil mining. Oil drilling is a controversial topic today, but back in the late 1950s, it almost got even more controversial. In 1958, the Canadian government was looking at ways to better extract bitumen from Alberta's oil sands. Dr. Manly Nadland, a notable geologist, believed that he had the answer. After watching the sunset in Saudi Arabia, Natland realized that an underground nuclear explosion could liberate the bitumen from the oil sands. Natland discussed the proposal with the U.S. Atomic Energy Commission, which was doing research into peaceful nuclear explosions as a part of Project Plowshare. The EC gave Natland the go-ahead and even stated that they would help him with the first detonation, planned to occur 10 kilometers, 6 miles, underground in remote Alberta. However, Natland's proposal met skepticism over its environmental impact, specifically the pollution of groundwater. Eventually, the Canadian government decided to move away from nuclear proliferation, both as a peace measure, and to stop Canadian nuclear devices from falling into Soviet hands. With non-proliferation taking hold, Natland's plan faded away and remains an obscure footnote in Canadian mining history. Number 2. SADM and MADM nuclear backpacks and landmines. As mentioned earlier, the United States was very concerned about fighting a land war with the Soviet Union and Europe. They developed a variety of odd weapons to fight the Soviets, usually revolving around small nuclear weapons, like the previously mentioned M29 Davy Crockett. Possibly the strangest nuclear versions of normal wartime weapons were the special and medium atomic demolition munitions, SADM and MADM, which were essentially nuclear landmines. The SADM, which saw the most use, was a small nuclear device that could fit inside a Special Forces backpack. A Special Forces operator using an SADM device would be expected to parachute behind enemy lines and use the small nuke to destroy key infrastructure. Operators could also use them in scuba dives. After a successful strike, the land around the explosion would be uninhabitable, slowing any invasion across Europe. SADM training took place throughout the Cold War but was finally retired. A related weapon was the MADM, which was a smaller version of the SADM backpack nuke. The MADM, which didn't see wide usage, was a low-yield weapon used as a landmine to disrupt troop movements. Fortunately, the SADM and MADM never saw combat. Number 1. LENR Household Nuclear Reactor. Most of the nuclear devices described here have been war-related, but Chicago entrepreneur Louis Larson believes that the future of nuclear reactors is to use them in the home. Larson spent most of his professional life bouncing between jobs, but in the 1990s, he began to investigate nuclear energy with the goal of creating small nuclear reactors. Since then, his name is synonymous with the field. Larson is looking at developing the low-energy nuclear reactor, or LENR. Larson's LENR could power a house with almost no emissions, and would be as small as a normal microwave oven. According to him, all of the technology and research supports the posse. All that is left is the engineering. Skeptics claim that Larson's LENR is suspiciously like the University of Utah's cold fusion reactor, which ended up being a hoax. However, Larson may be onto something. Recently, NASA began research into LENR power plants for houses and space planes. Physicist Joseph Zavodny takes Larson's research seriously and states that Larson's LENR research is fundamentally different from cold fusion. Zavodny is heading a NASA team tasked with developing house-safe nuclear reactors. While the idea may seem pretty far-fetched, the U.S. Department of Energy began putting small amounts of research money into Zavodny's work in 2013. We'll have to wait and see if it pans out. Thanks for watching the video. If you like the video, share it and click like and say your opinion in the comments below. Do not forget to subscribe to the channel. Thank you.